today I'm going to show you a phenomenon in object-oriented programming language, the way they have constructed. That is, you can make a Stack Overflow exception by just one line. So let's go ahead and check that out, alright? So let me open my Visual Studio 2017 here. So let me create a basic console app. So let's name this as a, let's give it a name. So let's see. So let's go ahead and click next. And as you can see, I have a basic console application. Alright, so now let me go ahead and add a new class here. So add class. Alright, so it makes this and let's give it a name. Any name would be do. So now here also I'm going to make this as public. Alright, now before we do anything, let's create object from that class. So t equals new test. Alright, now so if I initialize some variables here, so let's say int a equals 3, b equals 6, c equals x, 55, and let's declare a string also, string s equals hello. Alright, now this is nothing much a big deal here, so you can read the variables from here. So t dot, let me make sure I make this public. Alright, so I simply can, as you can see, I can read the values of these variables, so not a big deal. Alright, so let's have a look. So as you can see, I get value 3. So this is nothing special, alright, but we have a interesting thing going on. That is because this code block ran when we make this initialization. So these programming languages guarantee to initialize the variables when we assign the value to it. But now what happen if we do something like this? So let me get my test, t equals new test. What happened? So let me remove this error here. So as you can see, I don't print anything. Now this is the only line except this class, and this is the only line I have here. Alright, so this is the only line we have, right? Watch what happened when I run this. So nothing here also. So watch what happened when I run this. So as you can see, we have a Stack Overflow exception. See, we have a Stack Overflow exception right in this line, and this is the only line in this class. Alright, so what's going on here? Why this thing happens? So this is initialized as a normal variable, so we can insert others too. So for example, I can use int a equals 1, b equals 2, and c equals 3. Alright, but notice I even set this as public. Alright, so if I can use public, and there. So if I try to write this, so if I get the t dot a, and let's see whether we can. So again, without printing anything, this one throws a Stack Overflow exception. It shows like right here, but actual happens due to this reason. Alright, so why this thing happens, why the Stack Overflow exception throws? So that is the way these languages have constructed. So let me get my paint and draw a stack and heap diagram so we can have a good idea. So here I have this side my stack. So this is my stack and this is my heap. Alright. Now in my stack I have variables and heap I have objects. So when we check our code here, you can see I have sorry, not this one, this code. So this is the variable that I have in my stack. So I have a variable called t. Alright, so let me draw a line like this. So I have a variable called t here. Alright, now when this instruction executes, so let's break this down to like this. So test t, then t equals new test. Alright, so if we break it like this, as you can see now in my second line I am creating a new object. So this create a box like thing objects. Let's assume the object is a box in my memory, and now in this initialization it goes to this class and starts initializing its variables. So we have a here, so I have in this box, so I have a now initialized to, so now it's initialized to 1, and there's another variable called b. It is also initialized, the value is 2, and again we have a c that initialized to 3, and also we have a variable called t. Now this is not a value type, this is another object. Alright, so when the program encounters this instruction, it does something like this. So let me get my brush here. So it again create a box like this in the heap. Now this in the heap. Alright, and please forgive me for my arts, and this is also a object from this class. Alright, now that newly initialized object also initializes this variable. So we have a here, again is 1, b is 2, c is 3, and it also has a variable called t. Now again when the program encounters this instruction, the t equals new t, it again create, oops, get my brush, it again creates the object in its memory. Alright, let's create another object here. Now as you can see what's going here, again we have a, b, c. A equals 1, b equals 2, and finally c equals 3, and t is going to be another object. Alright, but as you can see, this creates infinitely and it never ends until you run out of resources in your machine. Alright, so this one creates another object, this again create another object, so this object creation is infinite. So that's why you get a Stack Overflow exception in this line by trying to create another object because of your system resources are exhausted. So if we remove that also, this one is still the same. So you can if you can make fun of this one by just simply adding a new object to the same class. This happens to me very often, but now it's less likely to happen to me. So this is something you must take care of. So if you just do this in the constructor, still the same thing. So if I create our default constructor here, so So this is still the same. So if I run it, so you still get this stack overflow exception in this line, and if you do the same in the constructor also, you will get the same result. Now this is also doing something like this. So you have constructor, this one calls this constructor back, and this it reaches this line, then it creates a new object, call this constructor, and so on, so on, so on. But you can prevent this by, so if you want this kind of variable, the only way to there are two ways. One is to use this as static. Alright, so if you use static, there's nothing happens. That is because, so I can terminate the program. So let's get so, so if I write those in the console, make sure I mark this at public. So if I run this, you'll notice I have no exception and I have the value printed out. So what happens with static is the object is shared among the instance of this every class. So this one initializes only one when the static initializer invokes. So the static initializer runs only once, whereas these initializers like this, the object level initializers runs when each and every time when a new object created. So that's why the exception generates when we use this without static. Alright, so let's go ahead and check the IL assembly code, so rather ILDSM, Microsoft Intermediate Language disassembled code for this instruction. Alright, so let me go ahead and remove the static. Let's see whether they are actually putting this code under the constructor, though we do not specify it in here. So let me first remove this constructor here. So I should have these two variables. So let me rebuild here, and let me open ILDSM program. Alright, developer command prompt 2017. So let's initialize. So ILDSM, if I type this one, so you will get the intermediate language disassembler. So let me open the assembly I have. So now we have this one. So let me maximize this. So I have this. So this is the class that we are going to test. So as you can see, we have cthrow, that means constructor. If I double click that, so as you can see, though I did not specify any constructor here, this one actually put that initializer code into a constructor. Alright, so let's do something here. So this is without a constructor. So as you can see, you have ld arg 0, that means first arg, and as you can see, you have a new object creation. So that corresponds to this line here. This is the first constructor that invokes, and it's trying to set the field, save that object in this field called t. Alright, now let's create a no argument constructor explicitly and see whether this one automatically inserted into the compiler when the compile time. So let's create a constructor. Alright, now I don't put anything right here. So let's see whether compiler insert those things. Alright, now I'm going to do clean and I'm going to rebuild. So let's have a look again. So we have cthrow here. So again, as you can see, no change there. That is because the compile automatically insert the code to this constructor. Alright, so if I somehow create this constructor like this, let's say a integer value v. If I initialize the field like this, so if this kind of thing happens, notice I can no longer have this one, so I have to put the integer value also. But if we do this again, I have a stack overflow. Alright, so let's see. So we have okay, I have to remove this. Let's see, let's create a no arg constructor too, otherwise I should have it. Alright, now let's see what happens. See, still I have a stack overflow exception. That is because this one try to create instantiate like this, and this one this one creates object again, and it finds the object in here and try to invoke this constructor, and this constructor invokes. Now let's see whether where this instruction goes. It seems at first glance I can imagine that this one may goes to this constructor. Well, let's see about that. So let me clean this one and let me rebuild. So let's go to the disassembler, and as you can see this class here, so I have the test. So I notice I have two CTOS now. Alright, so let's see. So notice this line. So this one, as I suspected, this is the this is the first arg constructor. So this is this line. The compiler automatically puts that to this constructor, no arg constructor. So basically everything in this line goes to, sorry, not this one, these two goes to no arg constructor, except this one. I believe this one is in this variable. So this constructor already contains the code. So that is why the phenomenon like this happens. So this constructor, so let me get this up. This constructor creates this object, and while now the constructor logic executes, it encounters this one, initializes, and encounters this one, initializes, encounters this one, also initializes, and finally it encounters this one and try to initialize it. The initialization is another object, and it creates object here, and that object constructor runs initialize, 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 and again initialize, try to initialize and create new object from this one, and that newly created object constructor again in turn run initialize, 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 and that constructor create an object for this one here, and that this object's constructor again do the same, and this process goes until the limits are exceeded. Alright, so that's what I wanted to share with you today. So I hope you enjoyed this video. So if you enjoyed it, click the like button, and also do not forget to subscribe to my channel, that is Fun Text with Hashan, and also please make sure to click the bell icon so you will be notified when I uploaded a new video. So with that being said, thanks for watching and thank you very much.